Let us see in this video how the mutual information is used to say about the channel. That means it is used to say whether the channel is noiseless or it introduces noise in the input bit, that we can comment with the help with the help of mutual information. So this is the binary symmetric channel. So if this probability, this conditional probability and this conditional probability are same, then it is symmetric. So here this is you already know this because we have covered the binary symmetric channel. So this is the probability y0 given x0, that is 1 minus p. Probability y1 given x0 is p. Probability y0 given x1 is p. Probability y1 given x1 is 1 minus p. So, and they have given the input probabilities. Px0 is 0.5 and Px1 is 0.5. Now here we have written the conditional probability or channel matrix, that is x0 and x1 are input, y0 and y1 are output. Then probability y0 given x0 is 1 minus p, probability y1 given x0 is p. Likewise here p 1 minus p. Now we obtain the joint probability matrix with by multiplying this row with px0 and this row with px1. Then if you add these values, you get py0. If you add 0.5 1 minus p plus 0.5 p, that is 0.5. That means column wise addition of the joint matrix will give the probability of output symbol. Now if you add these probabilities, you get the py1. So py1 is also 0.5. So you got the output probabilities. Now mutual information ix0 semicolon y0 means what? It is what the information you get if you have observed that y0 is received. That means you received a y0, then what is the information you get? That x0 is transmitted. That is mutual information ix0 given y0. That is given by log 2 probability of y0 given x0 divided by py0. So that is equal to log 2 y0 given x0 is 1 minus p, this one 1 minus p divided by py0 is 0.5. So you got this as log 2 to 1 minus p. Now mutual information ix1 semicolon y0, that means you have received y0. Then what you can say by the reception of y0, that what is the probability or what is the information you receive that x1 can be transmitted. So that is log 2 p y0 given x1 divided by p y0. Now y0 given x1 is p and p y0 is 0.5, that is equal to log 2 of 2p. x0 semicolon y1, that means you received a y1. What is the information it gives you? That x0 is transmitted. So that is log 2 probability y1 given x0 p y1. Probability y1 given x0 y1 given x0 y1 given x0 is p. So that is p y1 is 0.5, that is log 2 of 2p. ix1 semicolon y1 is you received a y1. What is the information it gives you about this transmission of x1? So log 2 probability y1 given x1 divided by probability y1, that is log 2 of 1 minus p divided by 2. It's not 2, it is 0.5. So probability of y1 is 0.5. So you got log 2 of 2 1 minus p. What is average mutual information? If you do the average of these things, you get the average mutual information, that is I capital X semicolon y. Now you here you can observe that x0 y0 is log 2 of 2 1 minus p. Similarly ix1 semicolon y1 is log 2 of 2 1 minus p. That is the mutual information of correct reception. This is the mutual information of wrong reception, that you have transmitted y0 and you have received a y0 and you have transmitted x1, you have received a y1 and you have transmitted x0. that is log 2 of 2p, log 2 of 2p. So the video is about what this mutual information tells about the channel. How we can conclude by observing the mutual information about the channel. So we will take the mutual information of correct reception. So this one, I x naught semicolon y naught. So we have took this one and we have computed already that mutual information is log 2 of 2 1 minus p. Now if p equal to 0, p equal to 0, that means there is no error. If you send y naught, you will get x naught. At that time, if you compute I mutual information x naught y naught, then you got mutual information as 1 bit, log 2 of 2 1 minus 0, that is log 2. So when there is no error, mutual information is 1 bit. If probability or error p is equal to 0.5, then I x naught semicolon y naught is 2 1 minus 0.5, that is here 0.5 into 2, 1 minus 0.5, that is 0.5 into 2, that is 1, log 2 of 1, that is equal to 0. So if it is 0.5, mutual information is 0. And if p is greater than 0.5, if you compute it, you get I x naught semicolon y naught is negative. So you have computed it with different values of p. So you observe that if there is no error, that means channel is not introducing any error, and at that time mutual information is maximum. So if you compute the mutual information I x naught semicolon y naught, then if it is maximum, then you can say that channel is not introducing an error. If it is 0, mutual information is 0, that means channel is introducing the, or we can say channel is not providing any information about what was sent, because mutual information is 0. That means you cannot say anything what was sent after seeing what is received. So this channel is a useless channel because it is not providing any information what was sent. Okay, so if the p is greater than 0.5, if you are getting mutual information negative, that means 100% there is a error. So this is a noisy channel. That means you have received one and and you are getting mutual information negative. That means 100% you have sent 0. If you have received one, you have sent 0. In this case, if you have if you have received 0 that and mutual information is maximum, that means you have transmitted 0. If you are getting mutual information 0 and you have received 1, you cannot say anything whether 0 is transmitted or 1 is transmitted. That means so same is written here, that mutual information is 1 bit, then channel is noiseless. 0, channel is useless, you cannot say anything. Mutual information is negative, then definitely error is there. So mutual information tells about goodness of the channel. So this video is all about how mutual information can be used to say about something, to say something about the channel. So what we have learned, that if you compute the mutual information and if you put the values of p, that is error, different values of p, then you can conclude something about the channel. That if mutual information is 0, that means channel is not providing any information. You cannot say what was transmitted after observing what is received. If mutual information is maximum, then you can say that there is a correct reception. That means if 1 is received, definitely 1 is transmitted. 0 is received, definitely 0 is transmitted. And if you get the mutual information negative, then you say that it is a noisy channel. If you have received 1, then definitely 0 was transmitted, and if you received 0, then definitely 1 was transmitted. So this is just the application of the mutual information in case of the channel prediction. That means you can say goodness of the channel with the mutual information.